Welcome to this presentation about our documentation. When I was first asked to present on this topic, I have to admit I was hesitant. I asked myself, who would want to learn about the books that nobody likes to read? I kid about this because software documentation has traditionally gotten a bad rap. While this may have been true 20 or 30 years ago, it's really not the case today. When I first started writing documentation, we released our software on floppy disks. Each of those disks had a file on it named README.txt. We knew by questions coming in that people were not reading that file. So we tried an experiment and put a copy of that file on the disk and named it secret.txt. Well, everyone read that file. Hopefully, we don't have to trick people like that nowadays. Let me begin by introducing myself. My name is Jim DeFabia, and I am the documentation lead for HPCC Systems. I started writing technical manuals over 30 years ago and have been fortunate enough to have been able to work with the same developers through a few different companies. Well, eventually we all landed here, and that has made for a great team. I'm going to talk about a wide variety of documents today, many of which I wrote or contributed to, but some that I had little or nothing to do with at all. When I say we in this presentation, I do not mean to imply that any of the credit should go to me. Everything that we have is the result of a team effort, a team that I'm proud to be a part of. So why is documentation important? Yes, hours of debugging can save you minutes of reading, but you all know that the converse is better. There are many reasons why documentation is important. Documentation can, if it's easily accessible, provide quick answers when you are stuck or need a quick answer. It can also provide all the details you need to thoroughly understand a complex topic. Good documentation needs to provide a path to quick answers and a way to dive deeper and get all the information you need to do your job. It can also provide a means to learn about new features, many of which can make your work easier or faster. Think about it. If a feature can save you just 5 minutes a day, think about how much time that can save over the course of a year. Good documentation can also help new hires get up to speed quickly without tying up other team members. You hand the new person a book or two and let them go off on their own and learn. After they get their feet wet, they can get to the tasks at hand faster, hitting the ground running. Now, one side effect of documentation is how the process of writing documentation can actually improve the quality of the software itself. I have a rule of thumb that I have followed throughout the years. If a process is hard to explain, it might need a better design. Quite often, a few simple changes can make something easier to use, and then it becomes easier to explain. Good documentation can also help current and future developers maintain code. In this fast-moving world, developers are responsible for larger amounts of code to maintain. The code was well documented when it was first introduced. It'll help developers understand it later, and that future developer might even be yourself. It's not always easy to remember everything about a portion of code a year or two later, even if you wrote it yourself. Author Damian Conway said it best: documentation is a love letter that you write to your future self. So what will we cover today? We'll start with productivity improvements, things we have done over the years, including the automation of our build processes and incorporating some basic testing into those processes. We'll also talk about an expanded documentation written by developers for developers in a place we call DevDocs. We'll talk about our current platform documentation, what we have now and where we're going. And we'll talk about some of the different types of documentation, including videos and blogs. And finally, we'll introduce you to our new interactive ECL, where examples on our language reference web pages become interactive. This is an exciting new enhancement we've made to help ECL developers learn ECL. So let's start with some of the productivity improvements we've made in our documentation process. In the early days, we had to produce the manuals one by one manually. In fact, I used to say they were called manuals because they required a lot of manual labor. On the day of a version release, we would almost always have to work late to get them all done. Thankfully, we're no longer in the publishing business because it's all automated now. Once we went open source, documentation became code. We were able to automate those build processes, including the compiled documentation. Now, this process still took about an hour to build all the docs. So more recently, we moved our build systems from our bare metal build servers and started building using GitHub Actions. The docs now take under 10 minutes to build. Now, in addition to building the docs, GitHub Action also gave us a way to extend the process to include some testing. This summer, one of our interns created an action that tests all of the hyperlinks in our documents to make sure they still work. You know, often we link to third-party websites, so the target of a URL can change out from under us. This test makes sure that readers won't ever get a 404 error when they click on a link. This action we're hoping can also be useful to other teams who have documentation stored as code in their repositories. You can see that more about that project later in the interns poster presentations. So all of this automation saves us a lot of time, but we lost one of our favorite excuses. I'm compiling. But seriously, when new tools and procedures saves us time, we can use that time to produce a lot more. But don't tell my manager that. So let's look at our doc set, beginning with our formal manuals. These are primarily delivered as PDFs, short for portable document format, a format that is cross-platform, making it highly portable and stable. It's been around for a long time, and it's served us well. Every browser now directly supports rendering PDFs, so you can actually read the docs without having to download them and open them in a separate application. We experimented with other formats such as Kindle and Nook, but PDF remains the most robust and widely accessible form. Now, we do publish several of our books as HTML web pages as well, and those are very useful too. In fact, we've made some improvements that we're going to see later, and are actively working on other improvements to our HTML deliveries. And by the way, our HTML outputs are also automated in the build process. The good news is that all of our documentation is stored as code, so we can easily adapt to other forms of presentation and have room for expanding in the future. You'll hear a lot about the benefits of documentation as code. There are basically three types of books that we have: user guides, reference manuals, and tutorials. User guides are task-oriented and application-specific. For example, the ECL IDE guide tells you how to set up multiple configurations and explains each option for each dialog in the setup. The Installing and Running the HPCC Systems Platform book provides all the details needed to install a bare metal system. The Containerized HPCC Systems Platform manual provides the instructions for deploying and configuring a containerized or cloud-native deployment. Reference manuals are used as references. For example, you want to use ECL to dedupe some records in a file. So you look up the dedupe keyword in the ECL language reference and you learn how to use it. Tutorials are step-by-step guides which you follow along to learn and get hands-on experience. Our popular data tutorial takes you through an end-to-end process of getting raw data, converting that data into a more useful form, also known as the extract, transform, and load, or ETL phase. Then we create an index, write a query, and publish that query to a Roxy cluster. The final portion uses WSECL to run that query and run some index searches. This tutorial was written for both programmers and non-programmers alike. It's simple enough for non-technical folks to follow, but complex enough to keep the programmers interested. It also exposes a new user to almost every aspect of the platform. Now, we're working on additional tutorials. In fact, this year we had an internship project where a new tutorial was written that uses our machine learning bundles. You can hear more about that project again in the interns poster presentation. So each of these different types of manuals is needed, and each serves a very specific purpose. Our online help repurposes the content of several of the reference manuals and delivers that content from the ECL IDE or Visual Studio Code. The ECL IDE provides quick access to the ECL language reference, the standard library reference, and the ESL language reference in the form of compiled help. You simply place your cursor on the keyword and press F1. That's the Windows standard key for help. It opens the topic in the Windows Help viewer. Now, for other platforms, our users are using Visual Studio Code as our development environment. In VS Code, similar functionality is provided using Shift F1, which takes you to the web version of those same references. The content is the same because they're all compiled from a single source. The direct benefit of documentation is code. We'll look a little deeper at those web pages later. We also have a video series. We're constantly adding new how-to videos to our developer series. We understand that some people prefer to read and other people prefer watching a video. It's a tic-tac world, and there's nothing wrong with that. We have a lot of information coming at us, and we need the shortest path to knowledge. So we need to provide more than one path to serve users with different preferences. Our developer series videos are typically short videos where they show you how to accomplish one task. Quick, to the point, but incredibly useful. Some of these are used to showcase new features. Others might show a new technique. If you haven't looked at these videos lately, I strongly suggest you give them a look. You'll find a directory of all these videos on the HPCC Systems website, as you can see in the screenshot here. They're listed in several categories to make it easier for you to find topics that interest you. And remember, once you're on the YouTube channel for HPCC Systems, don't forget to like and subscribe. We also have blogs and the Red Book and announcements. Oh my. Yes, there are many paths to knowledge. Blogs are a less formal way to introduce new features and technique. We try to publish at least 2 blogs a month. We don't want to overload readers, but we want to provide a steady stream of information. Blogs are where you'll find the latest cutting-edge details. These blogs are often written by the developer that implemented a feature, so you'll get inside information directly from the source. The Red Book is a unique collection of facts for system admins and ECL users alike. It provides useful information about upgrading the platform. If you're responsible for a deployed platform, we strongly urge you to read the Red Book for information regarding upgrades from one version to the next. While our goal is to make upgrades as seamless and transparent as possible, there are times when that is not 100% possible. The Red Book provides all the details you need for a smooth upgrade. For example, in version 9.8, we replaced the regular expression or regex libraries that was nearly seamless. However, there were some special cases where regular expression code had to be modified in special cases using Unicode. They had to be modified to ensure accurate results. We provided all these details in advance so teams that used regex would be prepared before upgrading. And all of those details were in the Red Book. Platform release announcements are another important section of our website. In that section, we list a few of the most important features in a new major or minor release. We like to call this internally the nifty features list. These announcements highlight some of the most important things in a release, but we still publish a full list of changes for each release, known as the release notes. And in the release notes, each listing has a link to the corresponding JIRA issue where you can see more details. We're continuing with our popular Tech Talk series. These online webinars provide another avenue of communication to users all over the world. The HPCC Systems website announces these talks when they are scheduled. It also has an archive of all the previous tech talks. I invite you to check them out. We also use our community forum to provide answers to user questions. Last year, we moved from hosting our own bulletin board type forums to using Stack Overflow. This allows us to answer questions without the need to maintain servers hosting them, allowing us to focus on the answers to questions and helping users. Last but not least, we have a new exciting effort we call DevDocs. DevDocs, or the Developers Hub, is a collection of documents written by developers for developers. This effort was started by encouraging, okay, we're really requiring it now, that developers provide details about new features and functions when they implement. These documents are useful to developers, collaborators, and users alike. Some of them are simple, some of them are very complex. They all go through the same rigorous scrutiny and code review as our source code does. Some will be used to gather the information to write sections in the formal documentation later, and others are only of interest to developers of the platform who will make calls into that code. Regardless, they provide useful details, especially when somebody has to make changes to that code in the future. The documentation team is formalizing all the details to help developers write these, and the contributor's guide will be placed where else? Right here in DevDocs. Let's take a look at what we have.
This is the HPCC Platform Developers Hub. As it says on the home page, this is a collection of notes and documentation for platform developers. Let's click on Get Started to begin. You'll notice the menu on the left. The first section provides guidelines for submitting documents or code to the repository. There are guidelines for writing C++ code and ECL code, as well as instructions on how to write docs. Some of the topics covered in the lower portion of the menu are ones that are already completed. For example, there's an entire section on Roxy which provides insight into the internal design and the inner workings of Roxy. Another interesting topic is work unit workflow. This section covers everything you always wanted to know about the life cycle of a work unit. Another section that we are building out is a user guide area. This is a section where we hope to get user instructions delivered quicker than our former docs. More topics will be added in the future, but we think this is a great framework for storing and sharing information for developers by developers. We are also sharing this framework and methodology with other teams in the company and hope that it can be a template for documenting code for other products and processes in the future.
So let's talk about interactive ECL. Interactive ECL provides, it's our latest nifty feature. Interactive ECL leverages our online references, both the language reference and the standard library reference. And with the help of lead architect Gordon Smith, one of the original HPCC Mavericks, we have made many of the ECL examples runnable from the code listing themselves. This provides the following workflow. Let's say a developer is writing some ECL code in VS Code and has a question about a keyword, for example, dedupe. All they have to do is place their cursor on the keyword and press Shift F1. This opens the default browser and opens the dedupe topic page from our website. There they can read all about it and see an example. If they want to experiment, they can click on the Run button and it opens a new tab with the ECL example code in ECL Watch's Playground, hosted on play.hpccsystems.com. From there, they can submit to the Playground cluster and see the results. You can modify the code and submit it again over and over again and see the differences each time. We think that this hands-on experience can help new users, and experienced users for that matter, learn more about the topic. Let's take a look at how it works.
In this demo, we'll start out in Visual Studio Code, or VS Code as we like to call it. You'll see here that I have an ECL file open. I'll place my cursor on the absolute value function, and I'll press Shift F1. The default browser, in my case that's Chrome, opens with the absolute value topic displayed. Notice that the example has two buttons at the top. The copy button copies a code to your clipboard, so you can paste it in another application like your ECL IDE or VS Code. The other button, which is the new button, is a Run button. If I press that button, I'll click there, you'll see that it opens the ECL Watch Playground with the example code already loaded. From here, I can submit it and see the result. You'll see here that the result of the absolute value of 1 is 1, and the absolute value of -1 is also 1. Now I can go back to my code, and I can modify it, and submit it again. And you'll see there that the result has now changed based on the new code. We think that this hands-on experience will help both new and experienced users learn more about ECL. Oh, and while we're here, let me digress for a second and show you a new feature that we added to the ECL Watch Playground functionality. Yes, there's now a syntax check button, which will allow you to check your syntax before you submit. We think it'll make using the playground easier. You press the button. If the syntax is correct, you'll get the green check mark. If for some reason it is not correct, you'll get a red X, and it'll show you your error message below, along with the line and column number, so you can fix your code and resubmit it.
So what's next? For the DevDoc effort, we're working towards providing as much support to developers to write these documents. As I said earlier, the guideline for contributors is being formalized as we speak. And remember, contributions can come in many forms. Sometimes as simple as creating a JIRA can be helpful, or you could write a new example or suggest a new tutorial. And we are open source, so we welcome these contributions from everyone. For interactive ECL, at this time, about half of our examples are runnable. There are many more that can be modified to enable them to run, and we're working on those right now. We've already worked out a way to include examples that require logical files to already exist on the Playground cluster. We hope that you give these a try, and if you have any suggestions for better or different examples, we welcome your suggestions and contributions. We're also looking into ways to incorporate AI, such as code explainers or an ECL-aware AI tool like Copilot. And that's something you're going to hear in just a few minutes. So in conclusion, we've had a busy year, but the work is continuing. We welcome your suggestions, contributions, and feedback. This slide has a list of URLs for all the resources we talked about today. And stick around, because coming up next, we have a very exciting presentation in this time slot. Connor Davis, who was an intern at one of our partners, DataSeers, he'll be discussing his project, the ECL AI Assistant, which uses Llama3 to create an ECL-aware AI tool to help ECL programmers. Thank you. And now, here's Connor.
Hello, my name is Connor Davis, and this is the LLM for ECL code generation using Llama 3 project. So just a little about me. I'm a fourth year at Georgia Tech computer science major with threads in intelligence and devices. Most of my experience with programming lies in Python, Java, and C. And recently I've taken multiple AI and machine learning based projects and courses, and this is where my interest in this project stems from. And also, I just finished an 8-week internship at DataSeries over the previous summer. So what exactly is this project? The primary goal of this project was to use an LLM to create a chatbot that can be used to turn prompts into ECL code. We wanted these prompts to be accurate, but limited them to more basic code due to time constraints. Additionally, we wanted the chatbot to be easily built upon to leave room for future improvement. So the relevance of the project is mainly important because languages such as ECL are generally lesser known, and this leaves them to have significantly less resources than more popular languages like Python. This can make the process of learning and developing much more difficult. A tool like this could serve as an aid to learning and developing, compensating for a potential lack of resources. Additionally, if this works for ECL, other languages could try to replicate this idea to accomplish a similar goal. So here's a look at the development process. To start, there were some obstacles that came up through the project. One thing that heavily limited our choice of LLM was the hardware limitations. The chosen LLM would run locally on a machine in our CEO Adwait's office, which couldn't handle some of the larger models. There were also some major time constraints as my internship was limited to 8 weeks. Because of this, we focused on working with basic functionalities. Additionally, coming into the project, I was generally unfamiliar with ECL as a language, meaning I had to commit time to training early on and would have trouble with more advanced code. Finally, the process of finding sample code was difficult as there weren't many resources online, which is just another reason for starting this project to begin with. For my general development process, I decided to work with the Llama 3 8B model. This decision was made by looking at benchmark performance, hardware requirements, and availability. Many models with high performance weren't publicly available for use cases like this, and Llama 3 generally had the best benchmark performance, especially for coding. Next, I worked on finding sample code to create prompts for the model. Almost all of this code came from the public HPCC Systems GitHub repositories, with a small portion coming from the ECL handbook. The gathered prompts and responses were divided by basic ECL functions such as sort, transform, project, and dedupe. Each function was initially given 25 prompts, which were used for prompt engineering with the local Llama 3 model. Below we have an example of a prompt and response. The response seen here is a piece of sample code found online through the GitHub repositories, and the prompt was created by me to show the model what it should be asked to produce this response. So here are the results of the project. The model was very responsive to prompt engineering. Minor changes in the prompts, especially since there was a generally low number of prompts, would make noticeable changes in the consistent responses from the model. This meant that it would have a high accuracy responding to basic prompts that were provided samples by me, but with more complex prompts, it struggled. Because of memory limitations due to the hardware and model size, I was forced to cut the prompts down to roughly 5 prompts per function, which was reduced by 20 from the initial 25 planned, with around 40 total prompts in the end across all functions. This still gave accurate responses to the basic functions, but there was a noticeable decline in accuracy, which could be easily fixed by adding more prompts in the future. So for future improvement, there's still a lot of room to grow. This was realistically just a proof of concept and just a baseline for where we want to go in the future. Because of the impact the prompts had in guiding the model, adding more prompts will make a very large impact on the accuracy of the model and what the model can cover in its prompts. The best way to go about doing this is to quantize the model. By quantizing the model, there will be more space to add prompts in the future, and it will only like lose minimal accuracy. Additionally, as I mentioned before, the hardware was very limiting. If we were to get a much more like robust machine, this could add more prompts on its own without any sacrifice to accuracy. Finally, in the future, when this is a more fleshed out model, it would be ideal to add a UI. As you'll see in the demo coming up, the UI right now isn't anything crazy and isn't very user friendly. If we were to add a UI, this could make the user experience much better. All right, now I'm just going to show you a demo. All right, so here we just have a quick demo showcasing the model in VS Code. I'll just give it one command into the terminal. Takes about 9 seconds to load this. Then pulls up a chat functionality in the terminal. And start by asking it to create a record structure and a table for just any arbitrary data set. Here we use cars. You can see it produces a record and then uses the record to create the table. Just ask it to sort by make. Creates a sorted table. Then ask it to dedupe the table we just sorted. You can see these quick 3 functions. Everything functions very well, like just as expected for these basic functionalities. Only issue we can see here is that in the record, instead of saying cars.make or cars.model, it just says make, model, and year here. That's just a like minor error that it makes because of the lack of example prompts. It doesn't exactly know how to set up the record structure. That's something that can be fixed over time when adding more prompts to these examples. And that's it for now. Thank you guys for listening and the opportunity to present.